Hello everyone and welcome to a new video of your daily Math Olympiad challenge. Today we're going to tackle a number theory problem from your junior Balkan Math Olympiad. So let's start. Let n1 and 2 etc. till n 1998 be positive integers such that this equation is true. So it basically means that n1 squared plus n2 squared etc. plus n 1997 squared equals to n squared 1998, and we have to show that at least two of the numbers are even. So for such a problem, it's trivial that we're going to use something with modulos etc. But in order to prove that at least two numbers are even, it would be good to prove firstly that it is impossible to have exactly one number even, and that it is impossible to have no numbers even. And this is very important because if we prove the first and the second statement, then the whole problem is going to actually be proven so automatically. Because if it's impossible to have exactly one number even, and if there are no numbers even at all, then it's going to be trivial that there are at least two numbers which are even. So that is the statement. So first we are going to prove this statement. So the fact that it's impossible to have exactly one number even. In this case, we have we have two possibilities. So assume that one of the numbers is even if n sub 1998 is even, then we have to consider both sides of this equation. So if he is even, then it's going to mean that the right side of the equation is congruent to 0 modulo 2, because of the fact that the number is even, so its square is also going to be even, and because of that it's going to be congruent to 0 modulo 2. But the left side is basically the sum of the squares of odd numbers. So this number is going to be odd, this number is going to be odd, etc. And we have this fact 1997 times, so it basically means that this side is also going to be odd at the end of the day. So it's going to be congruent to 1 modulo 2. And because of that, it's impossible that n 1998 is even. The second possibility would be that one of the numbers from the left side equation, so either 1 and 2 and etc. to n 1997 is even. That is the second possibility. But what does this mean? If one of the numbers is even, then we have exactly the same case but inverted. If we consider the modulo of the left side of the equation, because one of the numbers from the left side equation is even, then it's going to mean that we have 1996 odd numbers and one which is even. This is congruent to 0 modulo 2, and the sum of these numbers is also going to be congruent to 0 modulo 2. So the whole expression is going to be congruent to 0 modulo 2. But on the right side, we have an odd number. And we know that the square of an odd number is also going to be an odd number, so it is congruent to 1 modulo 2. And that is impossible, so we have proven the first statement. So it is exactly impossible to have exactly one number even. We've proven that. Now we're going to prove the second statement, that it is impossible to have no numbers even at all. So it's going to be impossible that all the numbers are going to be odd. And in this case, we can also assume that all numbers are odd. And in this case, we know that if n is odd, then we know that n squared e for random e is going to be congruent to 1 modulo 8. Now we're going to consider again the both sides of the equation. So if we consider the right side, then we simply know that the right side of the equation is going to be congruent to 1 modulo 8 because of the statement here. But if we consider the left side of the equation, then we know that something changes, because if every one of these numbers is going to be congruent to 1, if every one of these sides is going to be congruent to 1 modulo 8, then the sum of it is basically going to be congruent to 1097 modulo 8. And if we simplify this number, then it's going to be 5 modulo 8. And that is a big problem, because it means that this equation cannot be true for this condition. And because of that, we basically solved the problem. We proved that it is impossible to have no numbers even, and because of that, the problem is solved. Thanks for your attention, and please like and subscribe, and I'll see you next time. Have a nice day.